Thank you all for joining today. I'm here with Solar Oregon, and today's presentation will go ahead and cover smart electrical panel basics. We will go ahead and introduce you to Solar Oregon and our panelists for today. Then we'll jump into a presentation on smart electrical panels and how they can increase energy efficiency and energy resilience. We'll turn to today's panelists, and they're going to share their knowledge about this exciting technology. And at the end, we'll have a short Q&A session. So a little bit about Solar Oregon. If you don't already know us, we are a 501c3 nonprofit that has worked to encourage solar and storage adoption throughout Oregon for over 43 years. We do this by providing reliable and impartial consumer education, working to build the clean energy community, as well as performing outreach and some policy advocacy. We also host solarized campaigns, solar tours, zero energy showcases, and expert panel discussions on a range of topics involving solar plus storage. We are a member-based nonprofit, so thank you to all our members. If you are not a member, please consider joining, as well as donating to Solar Oregon today so we can keep these webinars going. Going to post some links in the chat that are resources that you can use throughout this webinar. And then we just wanted to also share that this workshop is made possible by Energy Trust of Oregon. Energy Trust is an independent nonprofit that was established in 2002 that provides resources to help enable customers of the investor-owned utilities in our state to use energy efficiently and to gain access to renewable energy. They offer key incentives for solar installation, and in 2022, we're also authorized to offer incentives on battery storage as well. So thank you, Energy Trust. Just a little housekeeping before we roll into the main presentation. Please put all of your questions into our Q&A box. If you put them in the chat, they might get missed during the Q&A session. Please note that we'll put any useful links in the chat, such as links to SPAN and a video about the SPAN panel, as well as the app, which are really good resources if you want to learn more after this presentation. And then finally, we're going to just launch a few polls before we get started, just to learn a little bit more about you and help us keep providing these great educational resources. The first one is just, where are you joining from today? So we'll just wait a moment while answers roll in. Great. So it looks like we have people coming from the Willamette Valley, Portland, Eastern Oregon, and even someone from another state. Go ahead and launch just a demographics poll just to, help us better know what audience we are serving with these presentations. Great, thank you all for your answers. And at the end of this presentation, we'll also have one more poll just asking you what you thought of today's webinar, and so that we can just keep improving our content. All right, let's get to it. Let's introduce today's panelists today. We have a really exciting group of experts. We have Joe Blinman from Neil Kelly, who is a 20-year veteran in the home performance renovation space. Joe has spent the last decade focusing on helping homeowners find energy independence and resilience through solar and battery storage, proudly serving Oregon with Neil Kelly and serving as a forerunner for sustainability in the community for over 75 years. We also have Will Musser, who is a sustainability advocate. He also has a SPAN panel installed in his home, so it's going to be great to get some insight from him and how that experience has been. Will Musser is a stay-at-home dad and a volunteer climate sustainability advocate with a background in financial services and residential solar. After earning a PhD in clinical psychology years ago, he volunteers with Climate Reality Project, Citizens Climate Lobby, Climate Interactive, Rewiring America, and Electrify PDX. We also have Nate Entrekin, who is from SPAN. At SPAN, Nate serves as a sales manager for the Northwestern United States, developing partnerships with installers of all kinds. Prior to SPAN, Nate was a sales manager for a national commercial energy efficiency firm called Carbon Lighthouse. And before that, worked for an impact investment firm investing capital in early stage startup enterprises working to improve social and environmental conditions in developing parts of the world. He holds a bachelor's degree from UCLA and lives with his wife and 2 kids in Oakland, California. We also have Don MacOdrum. Don is a senior project manager at TRC with 12 years of experience serving Oregon's residential energy efficiency and solar sectors. He currently serves as market transformation manager for Energy Trust of Oregon's EPS New Homes program. He focuses on whole building performance, based energy savings, including net zero energy, solar plus storage, electrical vehicle integration, and demand management initiatives. Don is from Toronto, Canada, and has called Portland, Oregon home for 13 years. Thank you to all of our panelists for joining today. And without further ado, I'm going to go ahead and turn it over to Don MacOdrum, who is going to share his presentation on smart panels.
Thank you so much, Nicole. So for my presentation, I think I'm going to go off camera just so I don't have to think about myself while I'm presenting. All right, so here we are. I'm happy to be able to join you today. As Nicole's shared, I'm Don MacOdrum and work on Energy Trust of Oregon's EPS New Homes program. With a special focus on helping participating new homes incorporate electric vehicles, solar, and storage, and to generally be ready for occupants to participate in load flexibility programs. The following slides, I've presented them to builders and verifiers in the last year, and in them I provide a brief history of the electric panel, followed by a case study of missed energy resilience. Then I wrap up with an overview of what can make an electric panel smart. Now, here we have our Energy Trust slide, and this is a pretty standard slide when you have a presentation from Energy Trust. And in fact, Nicole has already given us a version of this, so I'm going to just move through it. Thank you, Nicole. All right, so I just wanted to give you a quick overview of what it means to be part of the EPS New Homes program. EPS New Construction offerings encourage and support residential builders to strive to construct homes that are above the current code by working with trade allies all the way through the construction process. We offer free technical assistance and training, access to a suite of marketing materials, as well as cash incentives to help their businesses be as successful as they can be. Next slide, thanks. Okay, so I'd like to start my history of the electric panel with a reflection that while a myriad of construction techniques and equipment have been targeted for energy efficiency and technological improvements, I'm thinking of insulation and lighting, fridges and furnaces, water heaters and heat pumps, there remains one major piece of equipment that has been consistently overlooked, the electric panel. Next slide, please. So of course, the purpose of a residential electric panel is to safely distribute power from some source, generally from a local power provider's electric service meter, to different areas of the home. Branch circuits, which feed the outlets and switches in specific rooms or areas of the home, are responsible for getting an appropriate amount of power to the switches and outlets or appliances. Fuses and circuit breakers protect the wires, devices, and appliances on a circuit from damage. That can happen when devices overdraw current as a result of overloading a circuit, a faulty appliance, a short in the circuit, just like leaking current to the ground, or improper use. Fuses and circuit breakers are also critical safety features for the people who live in the homes. So here we have a photo of a common fuse panel that supplied homes with 120 volts and 30 amps back in the early 1900s. Okay, here we go. Next slide, please. Moving into the 1950s and early 60s, the most common service panel installations provided 60 amp fuse panels with one 240-volt feed. This particular panel was limited to being able to serve 4 15 to 20 amp branch circuits. And these are still found in some homes. All right, moving to a little bit more modern. In the mid 1960s, circuit breaker panels became the norm and are still in use today. Circuit breakers have the advantage of being able to be reset after they are tripped, while a fuse had to be replaced. Or I guess has to be replaced because some people still have fuses. All right. And then we've got a modern panel here. So for many years, typical circuit breaker panels that were installed had 100 amp service. 200 amp service panels became more common in the 90s. And either way, they have the advantage of being able to support much more branch circuits and providing twice the electrical capacity. Here, I believe we have a 200 amp panel. And I will say that if you don't mind going back there, Nicole, this is a very nice looking panel. This is a well labeled. It doesn't show, like all the rooms, that they serve, but generally speaking, this is a very pretty looking electric panel, and about as pretty as a standard electric panel gets. We will see even prettier ones soon. All right, these are the breakers. There's a few different types of breakers: single pole, double pole, which you can see sort of the second one from the right, that would serve a 240 volt circuit. You've got GFCI, they're second from the left, that can be independently tripped. That these are similar to the GFCI outlets that you have in your bathrooms to prevent faults due to water and hair dryers falling into the bathtub or whatever else. So I'm trying to move quickly through my slides so we have time for all the content. So I'm just going to stop there and move on to what makes an electric panel smart and how they can help a homeowner with solar plus storage. Okay, so this is the meat of my presentation right here. It's a case study. It's an overview of a real world problem. This particular family lives in a reasonably new home that was built in the last 10 years. The home has a heat pump for heating and cooling. It is well insulated with efficient windows. It has an 8 kW solar PV system paired with a 27 kWh battery storage system. So if you're familiar with like a Tesla Powerwall, that's a double Tesla Powerwall. And you need that to be able to power a heat pump. So that's part of the reason that they ended up getting the double, but also just to extend their battery storage. The problem is that we had a terrible ice storm in February 2021. And it's, there was record snow over a 48-hour time frame, followed by a major ice storm. Thousands of homes throughout the area lost power for multiple days due to a spate of down power lines. Now, this home in particular lost power around midnight, while everyone in the home was asleep. And once the utility connection switched off, the battery jumped in to manage the home's electric loads. But given that outside temperatures were below freezing, maintaining the thermostat's minimum overnight temperature of 66 degrees was a big lift for the home's heat pump, which in turn drew down the battery as the occupants slept. And when they awoke, the temperature in the house was nice and toasty, but the battery was completely depleted. So what could they have done differently? Are there any technologies that could have helped them? Well, for starters, they could have purchased a larger battery. I'm not sure how much would have been enough, but likely twice the size would have gotten them through the night with some to spare. But that's a lot of over-engineering to address a limited use case. The more practical solution would be to have a system in place that shut out the heating system from the battery, at least until the occupants had a chance to wake up and assess the situation. A protected loads panel could have helped them. though they would need to turn to space heaters because they wouldn't have had the heat pump on that protected loads panel or accessible to the protected loads. But smart load controls, on the other hand, could have allowed the occupants to preset the heat pump as a non-essential load. That way they could have woken up to a slightly cooler house with a full battery, or at least a more full battery, to strategically navigate the power outage. Okay, so I'm just going to give you a quick background on the different types of smart stuff that goes into a panel or supports a panel, and then I'll pass it back to the folks. All right, so next slide. This is just an overview of some of the things that go into a smart panel. There's there's software controls of breakers. There's maybe a control through an app. For example, Leviton electric panel can be turned into a relatively smart panel with smart breakers installed with a communication hub, allowing the breakers to connect with the Leviton cloud control platform. This serves particular purposes, data monitoring, use monitoring, and so on. It's not a full solution when it comes to, the use case that I just described. Next slide. Smart breakers could help if you had a whole home backup situation like the case I just described, and the smart breakers were serving some of the major loads. Then that might be able to help. They provide intelligence and monitoring of the load usage, and smart breakers have a place in the market. Next slide. Smart load controllers. This is where we're starting to get into some serious functionality. They are a step away from a full smart panel. They provide access to about half the loads on the panel. And can be controlled in a relatively similar way. During a power outage, they would allow for load prioritization when combined with solar+storage. But they're about the same size in terms of the number of loads that you'd have access to as a protected loads panel. All right, so finally, a true smart panel is an all-in-one package which the box, the chassis, all the individual breakers, and the mechanism for connecting the panel to the cloud-based platform control or to a local app is integrated. Span panels, for example, allow for monitoring of all the panel circuits. They allow for remote on-off circuit control of every circuit through the app. Span panels are designed to streamline adoption of solar+storage. Their founder was a former head of Tesla's energy storage division. And their product is involved in a wide variety of pilots throughout the country to explore its various value streams to utilities and energy aggregators. And we'll hear more, of course, throughout the presentation on that. And so that's it. I just wanted to make sure that everyone had a good sense of the technologies that are out there, the history of electric panels, and with that, I will pass it back to you, Nicole.
Thank you, Don. Thanks for presenting that. It was great to hear a little bit more about the history and how smart panels can benefit homeowners. So with that presentation ending, we're going to go ahead and turn to our panelists for some panelist questions. I'll get those started. The first question, Nate and Joe, how do smart electrical panels aid with energy resilience?
Sure, I'll start with that. Actually, I'm gonna steal your analogy again, Nate.
Go for it. Yeah.
So prior to the smart electrical panel, you could use this analogy. It's like driving a car with no speedometer or fuel gauge. You don't know how fast you're going or how much gas you're using. So when pairing a span smart panel with a solar plus storage system, day to day, or let's just rewind even further, just a span smart panel without solar or storage, or just solar with no storage, all of the above, it gives you a micro or macro view into how you're consuming electricity. You may have an appliance plugged in that you're not using that's actually drawing electricity and costing you money. So the smart panel allows you to be able to make your home more energy efficient in that regard, but also provide more energy resilience during an outage. So, the grid goes down, you've got your solar and your battery, or maybe just a battery and the SPAN smart panel. It allows you to extend how many hours of capacity your battery can give you during an outage, because you can have that macro control and see exactly what is being ran, and being able to toggle on and off those circuits to extend your battery output during an outage. So that's just one way. Nate, do you want to compound on that?
Yeah, that was beautiful. Thanks, Joe. I think that's an excellent example of how SPAN adds to the resiliency of homes. I think of that as sort of two elements to this question. There's sort of like upstream and downstream resiliency, and what Joe just described kind of is what I think of as like the downstream resiliency, like in the homes. How do homes respond to how do they respond to the need, or like the insufficiency with the electrical infrastructure today? And then upstream would be like, well, there's an issue right now that utilities have with the increased demand for electricity as homeowners are continuing to like add electric loads to their homes, but our current electrical infrastructure is frankly like insufficient to support the degree of electrical demand that we're seeing across the country, and that will only continue to increase as people transition off of gas appliances and adopt cleaner energy resources in their homes, like electric heat pumps and electric water heaters and electric induction ranges in their kitchens, et cetera. And these are all things that have, that massively increase the strain on electrical infrastructure needed to support this type of modern clean energy home. So an example of this, just to like make it tangible, would be like, come home from work and everybody's coming home from work at the same time, and it's, if people are plugging in, it's really hot outside, people are plugging in their electric vehicles and starting to cook the dinner for their families and turn on their AC, and the grid becomes extremely strained at that time. And that's when we start to see these rolling brownouts or blackouts, right? And the way I think about it is the grid is like a massive electrical panel, and the main breaker trips during those times, and we have to reduce demand in order to decrease the strain on the grid before it will allow us to turn everything back on. And this is where SPAN can help, right? This is literally our mission as a company, is to help people transition away from the burning of fossil fuels in their homes by adding cleaner energy appliances while using the infrastructure that exists today. So while grids are scrambling to upgrade their electrical infrastructure, they're also excited about SPAN. And Don alluded to this a few minutes ago, because SPAN has the ability to intelligently balance and pause loads when those individual homes are nearing electrical capacity. So what this means is, or what this could mean for utilities, is that they may not have to invest billions of dollars in upgrading their electrical infrastructure. Instead, they could partner with technologies and solutions like SPAN that enable homes to operate more efficiently with the infrastructure that we've got today, while at the same time adopting clean energy solutions like solar and batteries, all with like a centralized mobile-based dashboard, as Joe described, like a dashboard that you have when you drive a car, that helps them drive their homes as efficiently as possible. So there's a kind of both the upstream and the downstream elements to resiliency.
Thank you. So if homeowners are looking to increase this energy resiliency and energy efficiency of their home, can you kind of describe what the installation process would look like, and what permits look like as well?
Sure. Yeah. Installation of SPAN, it's pretty straightforward, actually, because it is a certified electrical panel. And depending on where and how it's being installed, it could be installed as a sub panel or as a main panel. And the process for installing it is just like installing any other main panel in a home. Part of the beauty of SPAN also, though, is, as we've said, is it does have the ability to intelligently balance loads. And there are some unique allowances for smart home energy optimizers like SPAN. SPAN has another certification. It is a UL certified energy management system. And that's an important certification because, and this gets a little technical, but according to the National Electric Code, the ruling body of what you can install and how you can do it in homes from an electricity standpoint, according to this code, if you have a UL certified energy management system, SPAN, you can actually ignore the added load calculations associated with the addition of an EV charger. That's just one example of how SPAN can help people add more large electric loads to their homes without the need to upgrade their panel or their service to their home. So now more and more, we're seeing people get smart panels in order to get electric vehicles. Another example of this would be, you've got, let's say, a home with a 200 amp service and a 200 amp panel, and you just bought your first electric vehicle. You bought a Tesla and you're all excited. You drive it home and, hey, now I need to install I want a level 2 charger for my new shiny Tesla. Unfortunately, now you need to upgrade your panel and upgrade your service. Maybe you need to go from 200 amps to 400 amps. That could be really expensive. The permitting process alone could take a really long time. Oftentimes now, getting SPAN actually is going to be cheaper. You can install your level 2 charger much more quickly, and you got SPAN, which gives you insight into the whole home. Of course, not just the EV charger.
Thank you. Will, as a homeowner who has SPAN installed in their home, can you tell us a little bit about your experience with installation and your experience with the smart panel?
Sure. Thank you for that. My overall experience with SPAN has been great. The installation really was not that disruptive in terms of like replacing the existing panel. It met my timeline and no surprises. It took like I think 2 full days to completely replace it and add back all the breakers. Also, just I've learned a lot about the actual SPAN panel itself and what it's measuring, and then coordinated with the app, learning more and more about the functionality and the different features, and then learning about the different electrical loads of the entire house, and what circuits and what appliances use, what different noises that you hear when some of them go on, like, and you can kind of look at your app and be like, oh wow, that's drawing a lot more power, and you can see in real time pretty much how it's pulling the loads basically either from solar or the grid whenever it requires the electricity. So I've been very, very happy with the decision to install SPAN.
And Will, when you were, embarking on your smart panel journey, what resources did you find helpful to kind of answer your questions and get you started?
Yeah, the contractor was very, very helpful in kind of discussing some of the pros and cons, and considering different, SPAN versus Lumen and the different interfaces, and going online, reading a lot of different articles, learning more about the different kind of options and things like that, different functionality. Those were very helpful. And yeah, the SPAN website, as Nate will probably attest to, is very, very informative and educational. There's also many YouTube videos, some of which are more helpful than others, and you can get into the weeds if you're really interested. And then there's different tutorials and videos, and kind of even a simulated video or kind of click through for learning the app, and basically before you would install the SPAN, you could actually take a look and see what you get when you click through this SPAN app.
Thank you. Nate and Joe, are there any other resources you'd recommend?
I think Will just touched on most of them. Our website, we've tried to make it as self-explanatory as possible. Just to reiterate, there's a lot of good content on YouTube. There's a lot of good product reviews. It's a new category of technology, and so people, like, our biggest competitor is a dumb gray box that's been around for 100 years, and so this is something that people are excited about, and it's sort of like changing homes into smart homes. And there's a lot of people who are passionate and like to talk about it online. And I think a lot of homeowners find those resources helpful, in addition to what's just on our own website. I also think that, like, it's helpful for people to just hear some anecdotes about, like Will just provided, how people are actually using SPAN to increase the efficiency of their behavior. I use SPAN as a diagnostics tool in my house. My stories are maybe people take them with a grain of salt because I work at SPAN, but I'm obsessed with my SPAN panel. I think, like, my wife is frustrated that we have SPAN because I've become so, like, dialed into how and when I'm using energy. And like, my 5-year-old daughter goes and sits in front of the space heater after she takes a bath, and I'm like, now I pull up my SPAN app and I look at how much energy that space heater is using, and I'm like, put on a coat, like, what are you doing? Like, turn that thing off. And I have SPAN. My family, I'm one of 5 brothers and sisters. We got a big family, and the 5 of us bought a house that we rent out on Airbnb on the Northern California coast, and we've had this house for about 2 years, and we put SPAN on it about 6 months ago. And this house doesn't have solar or a battery or an EV charger yet, but we put SPAN on it because our bill was always really high. We're renting this house out on Airbnb, and sometimes the bill would only, or the house would only be rented out for like a week out of the month, but the bill was still almost as high as if the home had been rented out for the whole month. So we were like, what the heck is going on? Why is the bill so high? And we had our guesses. We had, assumed that people might be leaving things on. And one time I got there, and the jets were on in the jacuzzi at the house, and they'd been on for 2 weeks before we got there, and I was furious about that. So we installed SPAN, and now our assumptions were confirmed, right? We were able to see, yes, people are leaving all kinds of things on in this house, and then those things are just running constantly while we're not there. And so now, rather than, I live in California, rather than driving 2.5 hours up the coast to go turn off the jets in the jacuzzi, we can just see that these 7 things have been left on, and just boop, 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 just turn them off with our app that we all share as a family. And our bill was nearly cut in half as a result of having that level of insight and control. So I like to say, like, we're keeping our house dormant when we're not there. But whether or not it's your second property or a rental property, or it might be your primary residence, but just having the peace of mind to, my wife always thinks she left the oven on. It's like this weird thing, but we go out on a road trip and we can pull up the SPAN app and look, and we can see, okay, no, in fact, the oven is off. But if it was on, we can just boop, turn it off from anywhere in the world. And having that peace of mind, I think, is in addition to reducing your energy cost and saving money there, just knowing that your home is secure and that everything is, you haven't left a space heater on or a large load or something's not, there's no fire hazards in the home when you're not there, I think is a big reason why people are excited about this level of remote control and insight over your home, which is the largest purchase most people will make in their lives.
Thank you. Thank you for sharing that. Before we get into our Q&A, we have one last question, and I'd like to just pose this to all the panelists. How do you see this new technology of the smart panel growing and changing in the next 5 years?
I'm happy to jump in with that. I think there's a number of answers here. One of the things that I'm most excited about is increasingly we are starting to see utilities change how they bill customers and moving to what we call time of use schedules. And this is increasingly prevalent across the country. And what that is, for those who don't know, is during certain times of the day when the demand for electricity and gas is the highest, utilities will charge more. And so you're on sort of a tiered rate plan. And And SPAN has unique scheduling capabilities. And again, I'll use the EV charger circuit as an example. With SPAN, through 3 or 4 steps, if you have an EV charger, you can it will just ask you, okay, what state do you live in? Okay, what's your utility? What's your rate plan? And then it'll ask you, do you want to charge on schedule? So in other words, do you want to only charge your car when it's the cheapest to do so? You say yes, select the plan. And then if you plug your car in outside of those hours, nothing will happen. But as soon as energy becomes cheaper, and for me at my house where I live in California, like I'm on a plan just like this, and at midnight my energy cost is half the cost of what it was at 11:59, and so at midnight my car starts charging. And more we'll start to see SPAN and roll out capabilities like this that will enable us to and guide us towards using energy when it's the cheapest to do so, based on the plan that we've got with our utility. I think like Joe's example here with the dashboard, helping us again, like it's guiding us or steering us to use our homes and to drive our homes as efficiently as possible based on the dollars and cents that it costs us to operate our homes. Maybe that's a long-winded answer, but that's one of the directions that SPAN is going that I'm super excited about.
Thank you. Any other adds on that?
Yeah, Nicole, I would add that, as a program that's very interested in helping builders make homes that have technologies that can be dispatched during load events, or that could provide other ancillary services to the utility grid. There's a promise to the SPAN panel and other devices that to allow the entire house to be an adjustable load. So while a 10,000 air conditioners could be signed up for a demand response program, and each one of them could see a reduction in their heating, or sorry, their cooling capacity for a couple hours, during an event. Homes that, a batch of homes that an energy aggregator could use during a load event could say, hey, everyone with a SPAN, we'd like to turn your 200 amp services down to a 100 amp service. And that 200 amp service down to 100 amp service could provide a huge amount of load relief during a stressful grid event. And so I'm very excited to see the potential of that. I know that there's pilots out there that are going on with this. On a different tact, I know that there's pilots to test, for example, the SPAN panel as utility meter grade information. So in place of tracking utility energy use through a meter, the panels are being evaluated as the means to measure that usage. And I don't know where that's going to go and what will be done with that, but that's an interesting study. So those are a couple of the areas that I'll be following over the next 5 years.
Absolutely. Just to tack onto that, I think with a technology like this, there are new ways of looking at the data, and there are a myriad of potential use cases for that data. And working with utilities, again, as I alluded to at the beginning, like as utilities become increasingly strained by the demand for electricity, being able to curtail grid demand in the way that Don just described is something that we're absolutely exploring with utilities. There are pilot programs going on, and we're just, potential partnerships on the horizon, but super exciting potential future application for SPAN.
Thank you. That was just great to hear. Really interesting to see where the technology might be going. Before we start our Q&A session, we are just going to do that last poll that I mentioned. So I'm going to go ahead and launch that now. And then while we give time for the answers to roll in, I just wanted to let you all know, thank you for attending the event. We do have some other exciting events coming up. We do a How to Go Solar Plus Storage as a webinar once a month. So check our website for that. We also have a Green Energy Series talk on June 3rd, and that'll be a webinar as well. And we also have an exciting in-person event that we're actually working with Don and Atijo on, and that will be a Solar Plus Storage open house on the 17th. So check out our website if you're looking to join some other events and learn more about solar and storage. And we'll go ahead and roll right into the Q&A. All right, I'm going to pull that up. And just as a reminder, any questions you have, just throw it into the Q&A box. All right, so first question. Do you see the need for a 400 amp service for 100% electric, 300 plus square feet home with 2 EV chargers? So I'm just going to go ahead and read off the question, and then panelists, do you want to see if you want to tackle that? So do you see a need for 400 amp service for 100% electric, 300 plus square foot homes with 2 EV chargers?
This sounds like a very
Specific question.
very specific question. I feel like there is a specific home in mind here. I would say it depends. You may. I'd consult with your installer, who you're working with, your local electrician or solar installer, to determine what the calculations require based on the loads that you're looking at putting in your home. SPAN can certainly help you optimize the efficiency of your home, and with EV chargers, as I described earlier, but also with solar and things like that, and batteries. Joe alluded to the extended duration of batteries with SPAN. So there are lots of ways that SPAN can help, but in terms of whether or not you need to go from 200 amps to 400 amps or something like that, I would certainly consult with your local installer who's doing the electrical work on your house.
Thank you. Yeah, that is a great answer. And for any super technical questions, it's great to work with your installer, your contractor, to get those answers, because they're going to be able to look at your sites specifically and analyze what loads you have to see what works best for your system. All right, next question.
Nicole, sorry, Nicole, do you mind if I
Yes.
just jump in on this one?
Yes,
I
please.
just wanted to share that Pacific Gas and Electric, PG&E, did a study for electrification down in their service territory, and they determined that 100 amp services are equivalent for the vast majority of electrification. So they talked, and this was actually specifically a part of a study to see if smart panels were necessary in general. And they paired this evaluation with smart splitters, devices that allow, for example, a dryer and an EV charger to share a 40 amp circuit. And, when the dryer is not on, the EV has access to it. And when it's not, it's when the EV charger is not available, then the dryer is good to go. So there are different devices like that as well to help folks manage, but I also defer to folks talking to their electricians and their solar installers.
Yeah, there's a lot of products like that that I think are fantastic, and maybe cheaper alternatives to SPAN. In that example, you wouldn't be able to do both at the same time. It's kind of one or the other, but enable you to electrify your home and add more things to it without a potentially very expensive service upgrade to your home. And remember, with SPAN, you don't have to count the EV chargers when you're adding those loads to your house. So another option there.
Great.
Just,
go ahead.
Just it's not exactly the same, but just I wanted to give my anecdote is that our home is 100% electric, 3,800 square feet. and we have one level 2 EV charger, and we have 200 amps and with the span panel, and we have no issues, knock on wood. I'm just I don't know. I would think it would be very infrequent when you would have 2 EV chargers simultaneously kind of being employed at the same time, but that it may be above my pay grade.
Thank you all for those answers. We're going to jump into the next question, and I'm just going to combine a couple as they look related. So who are some of the major smart panel manufacturers? And then what is the difference in pricing between a smart panel and a smart breaker?
I'm happy to answer that. Or Don, I don't know, do you want to take that one?
Nate, I can't take away your opportunity to talk about your competitors.
There are other options on, and Don alluded to some of these in his presentation earlier, the Leviton panel and the Lumen panel, and there are others coming to market as well. At Span, we're the only company to go all in on recreating the electrical panel. There are these other options that are a little bit cheaper, and I think generally have less functionality. And like the different, like Leviton requires these smart breakers, and those the breakers are what make the panel smart. You do need those breakers in order to have visibility and control over those circuits, and you can turn, in many cases, you can turn those things off with your app, but then you can't actually turn them back on. With Span, you can turn them off and on, and you have visibility into your entire house because you've replaced literally the panel itself. So I definitely do your homework, educate yourself, and think about what you actually want and need. And it may be that there's a really good solution that costs less that's not Span. And we're at Span, we look at the competitive landscape and the emerging new products out there as a really good thing. It's validation of the space, but also drawing attention and helping people optimize their energy use. And that's our mission as a company, is to help people do that, to get more out of their homes and to adopt cleaner energy resources like solar and batteries. And if there are other smart panels that help you do that, that's fantastic.
I'll pipe in real quick too, and add on that. So in my experience with estimating jobs and taking a look at different products, mentioned the Lumen and the Span, I found that just like Nate said, they're all in with that unit. For the functionality and the ROI, I would say that the Span, offers the best bang for your buck.
And I'll just do a final wrap up to say, yes, there's these separate units that control a certain amount of loads, which are your Lumen and your Adapt Energy load controls. The smart breakers, there's a variety of manufacturers of smart breakers that can go into a standard panel. The Lumen breakers need to go into the Leviton breakers need to go into a Leviton panel. And then the last thing, of course, there's smart outlets and smart lights that can individually be controlled. So that's sort of a different layer of control. And then lastly, on the category of a smart panel similar to Span, there's the Schneider Square D, which has some market penetration, but I'm not totally clear on its availability and where it's available. But that's another product that's meant to be ultimately a competitor to Span. But I don't know of its availability and how in the market they are.
And Don, you mentioned some of the different options. One of the questions we had was, can you just have like 1 or 2 smart breakers on a panel, or do you need a whole smart panel?
The certain smart breakers are designed to just 1-for-1 replace a standard breaker.
Thank you. And what is the upper end of the electrical panel capacity? Could it be used for like private side metering or for like an unmetered tenant space?
Yes, our panel, the span panel that we've got today is it comes with a 225 amp bus bar and a 200 amp main breaker that can be derated down to 100 amps or anything in between. So anything from 100 amp to 200 amp panel is what span can be. And yes, anytime it can be used for any type of sub panel, right? So, or any type of main panel where applicable. So if there is an existing sub panel there and you want to replace it with span, that works just fine.
And does span just have like a cost for installation, or is there also like a reoccurring monthly fee?
There is no monthly fee. So span does require internet, but you buy the product and you've got the product and all the software that it comes with. So it does require internet. That needs to be the primary mode of connectivity, but there is also a built-in cell card into every panel. So if you ever lose internet for any reason, it instantly defaults to a cellular connection, so you can continue to access your panel via cell service. And that's a cell service plan that span pays for. So again, there's no monthly cost to the homeowner for that either.
And does the cost just vary based on your system needs, and or is it a set fee?
It's based on your system, the configuration of your home, whether it's, the cost depends whether it's a new construction project or a retrofit project, and how simple your existing electrical infrastructure is in your house. It may be very complicated, especially if you live in an older home. And so then it's just a matter of how much control you want. If you want to relocate loads out of existing sub panels and land them in a new span panel, or if you want to just swap out your existing sub panels for span panels, there are always many options. And so unfortunately, it's not a crystal clear cookie cutter answer for span costs this. It sort of depends on the complexity of your home. But again, I'd go to your installer, ask them to check out your home and assess your needs, see what you're really looking for, and they'd give you a price for the project, a quote.
Then we had a question about electric vehicles, and so how does a smart panel work with an electric vehicle, and are there plans to integrate vehicle to grid solutions with span panels?
Yes, so we do have our own EV charger product on the market. It's called Span Drive, and it is a really slick charging experience. I have this installed at my house here. I have the panel and the EV charger. The EV charger looks like a little baby span panel. It's a very similar aesthetic, and it just looks great. We could have a whole nother hour discussion about the charger, our charger. But to answer this question, our current charger does not have vehicle to home charging capability. This is a really exciting and new technology that is very nascent and has just been rolled out. I think Ford is the first company to announce this capability with their Ford Lightning. At Span, we are watching this very, very closely, and we're super excited about this innovation. It has not been built in to our current charger, but we are waiting to see how the technology evolves, and it may be built into future span chargers. Either way, the panel itself it's the brain of the house, and I can't think of a better way to integrate this type of new charging capability than to land in a smart electrical panel like Span.
Thank you to all our panelists. Thank you to our attendees for today. This webinar will be posted to our YouTube, and will also be emailed out to all the attendees. We hope to catch you at a future presentation, and that is all we have for today. But sign up for our How to Go Solar and Storage, and hopefully we'll see you there.